All right, indicator 16, day 1, we are going to be using what we have learned as far as solving system of equations, and we're going to be solving story problems. So it's really just the story problem version of elimination, okay? So in both cases, or in all of the cases for all of indicator 16, you're still going to have two variables. You're still going to be solving. It might not necessarily be an X and a Y. You can use any variable you want. We tend to get used to seeing the X and the Y. And so if having a different variable in there besides X and Y throws you, use X and Y. And we'll talk about that here in a minute. You can use other variables if you're comparing the cost of roses and the cost of geraniums, and you want to use an R and a G in your problem. I like to do that myself because when I'm writing out the problem, it's easy to see 13 roses is 13 R, and it just kind of makes sense to me. It connects in my brain, you know, and 11 geraniums. And so, you know, 11 G makes sense to me that that's 11 geraniums. And then when you solve for R, it's easy to remember that that's the roses cost and that kind of thing. So picking your variables, it's an individual thing. It doesn't matter to me which variables you pick. I will say right off the bat, I would never use an S as a variable. I think we've talked about that. They look too much like fives. So I wouldn't use an L unless it was a capital L, obviously, because it'll look like a 1, that sort of thing. So just be smart about what you pick as your variables, okay? All right, so all of day 1s should be ones that you just have to add and subtract. At the most, you'll have to run a negative through it, okay? Day 2s gets into ones where you'll have to do the multiplication step in order to kind of push the elimination a little bit harder to make it happen. But all of day 1s should, if you write your equation right, should line up to where you, like I said, at most you just have to run a negative through to get something to eliminate. All right, so let's look at this first example. We've got the difference of two numbers is 4. Their sum is 24. Find the numbers. Well, our two unknowns are the two numbers. So if you just want to assign an X and a Y to represent, X represents one number and Y represents another, then that the first equation you could write would be that the difference of the two numbers is 4. So that would mean that X minus Y would equal 4, because that's saying the difference of one number, or the one number minus another number, is going to equal 4. The other clue or the other equation that you're going to write is that the sum is 24. So that means that X plus Y is 24, because we're talking about the same numbers, right? The same numbers have a difference of 4 and a sum of 24. Well, when you write two equations, you can set them up and you can solve them as a system of equations, and you can solve for X and solve for Y. Well, at this point, it should look really familiar to you. And in this case, right off the bat, the Y's eliminate. You don't even have to do anything as far as running a negative or any kind of manipulation to either equation to get something to cancel out. And so remember that this is 1X and 1X, and they're both positive, so it's an addition problem. So it's 1X plus 1X, which is 2X, equals 4 and 24 are both positive. So it's 4 plus 24, which is 28. And when you divide both sides by 2, you get that X equals 14. Okay, that's half of our answer. We know one of our numbers is 14. Now we can plug back into either equation to find what the other number is. So I'm going to use that bottom one, X plus Y equals 24. In place of X, now I can put a 14, because I now know that X equals 14. 14 plus Y equals 4. Sorry, I used the wrong one. I wanted to use the bottom one, equals 24. There we go. Okay, so I'm using the bottom one. X plus Y equals 24. 14 plus Y equals 24 when I plug what I know about X. And when I subtract 14 and subtract 14, I get that Y equals 10. So the other half of my answer is that Y equals 10, and that's what you would circle as your final answer. One number is 14, one number is 10. Does that line up with the clues in the story problem? Well, the difference between 14 and 10 is 4, and the sum of 14 and 10 is 24. So it does check out. Okay. All right. So let's look at our second equation. We've got Mel and Bill are selling fruit for a fundraiser. Customers can buy small boxes of oranges and large boxes of oranges. Mel sold 13 small boxes of oranges and 1 large box of oranges for a total of $80. Bill sold 5 small boxes and 1 large box for a total of $40. Find the cost. It's always important to look at what the question is. To know kind of what you're solving for. So find the cost. First of all, that tells us our answer is going to be money, because all story problems need a label. And we're finding the cost of a small box and the cost of a large box. So if we set this up as equations, the first thing I need to do is decide what I'm going to use as variables. Well, a small box and a large box, that would be an S and an L. And I don't want to use an S because it tends to look like a 5. So I'm just going to use an X and a Y. Because X and Y don't mean anything. They don't, I'm not using variables that match words that kind of make something mean something. I need to have a key off to the side that tells me which one I'm calling which. And you have to do this if you're going to use X and Y, except for in the example like number 1. It's just they both represent a number. But in this case of example number 2, I'm going to have X's represent the small boxes, and I'm going to have Y's represent the large box. And the reason I have to do this is because when I'm done solving, I need to remember that X is solving for the small box. Okay. So then let's look at, do a couple highlighting here. So right here, I've got that Mel sold, this is Mel's equation, 13 small boxes and 1 large box, totaling $80. So to set up Mel's equation, I'm going to have 13, and then I'm going to use an X to represent the cost of each one of those boxes. I know he sold 13 of them. I don't know how much it costs. That's what I'm finding. Plus, he sold 1 large box, and I know my large boxes are represented by the Y's. And Mel made a total of $80. Okay, so that's the first equation. Now I look at, get a different highlighter color here. Now I look at Bill, and Bill sold 5 boxes of small oranges and 1 large box, totaling $40. So for Bill, I'm going to set it up that he has 5X or 5 small boxes, plus he sold 1 large box, and he made a total of $40. Now it should look very familiar to you, set up that you can solve it as a system of equations. And because I have plus 1Y and plus 1Y, I do need to run a negative through either the top or the bottom, and it doesn't matter which. So I'm going to make each one of these a negative. So negative, negative, negative. I ran a negative through every one of those. And now I can solve it just like I did in indicator 15. So 13X minus 5X is 8X. The Y's cancel out. 80 minus 40 is 40. I divide by 8 and I divide by 8, and I get that X equals 5. Now I'll worry about writing my actual answer here in a second. Let's just solve for my other variable. So knowing that X equals 5, I can go back to either one of these original equations. I'll pick the top one. And now where I see an X, I can now put the number 5 in. I can plug that number in because I know part of my answer now. So 13X would be 13 times 5 plus Y equals 80. And 13 times 5 is 65. So 65 plus Y equals 80. And then I subtract 65 because I want to get Y by itself, or I want to solve for Y, and I get Y equals 15. Now I need to actually write my answer to answer the story problem, right? Story problems always need labels. And because I used X and Y, I'm going to go ahead at this point now and say that my final answer I'm going to circle is that a small box sells for or equals, and then small was X, so that would be $5. And then my large box was $15. And that's what I'm actually going to circle as my final answer. Okay. Small equals $5, large equals $15. And you can kind of see why this right here, what I did at the very beginning, Why that comes in handy is because, one, throughout my problem, I can remember that I was using X to represent small. And when I get done at the end, when I go to write my final answer, I don't want to just write X equals 5, because that doesn't really mean much when you're talking about a story problem. What does X represent? Well, you can look back at your key and see that X represented the smalls, and you can write your final answer. And then again, find the cost. So that means your answer needs to be money, okay, because you're looking for the cost. So be careful how you label these. That is it. That is all I had on the original examples for day 1. So I do want to go in and I want to, you don't have to write the whole story problem down. Let me find which one I want to use here. Yeah, I want to use this one. So I want to do this example. And again, you don't have to write the story problem out. I just want to show you how to set this up. And this is a good example where I can use variables here that make sense. So I've got high school A and high school B are going on separate trips. The senior class at high school A rented and filled 13 vans and 6 buses for a total of 298 students. High school B rented 10 vans and 6 buses for a total of 268 students. Every van had the same number of students in it as did the buses. Find the number of students in each van and each bus. So first of all, I'm finding the number of students. So that tells me that my final answer is going to be students as far as my label. And I want to find the students in each van and each bus. So I'm going to use V and B because that to me is going to make a lot of sense when I'm setting this up and solving. So when you look at high school A, okay, you look at high school A, they rented and filled 13 vans and 6 buses for a total of 296 students. So that means I'm going to set this up that there were 13 vans plus 6 buses, and B's can really look like 6s. So I'm going to use a capital B here. There we go. I'll use a capital B. 13 vans and 6 buses held a total of 298 students. And then when you look at high school B, okay, high school B filled 10 vans and 6 buses for a total of 268 students. So I'm going to set that up as 10 vans plus 6 buses held a total of 268 buses. And now again, this should look very familiar from this point as far as solving it, okay? I have 6 buses and 6 buses, which means if I run a negative through one of these, I can get the buses to eliminate. And then that means I'm going to be solving for the vans first. And if I do that, then it means 13V minus 10V is 3V. And 298 minus 268 is 30. And so when I divide both sides by 3, I get that the vans hold 10 students, right? The vans hold 10 students. So now that I know the number that gets plugged in for V, I can go back up to one of my original equations, and where there's a V, right, I can plug the number 10 in. So that means I'm going to go back up to the top and I'm going to do 13, but in place of V, I'm going to put what I know now, which is that each van holds 10 students, plus 6B equals 298. And 13 times 10 is 130 plus 6B equals 298. And I'm going to subtract 130 from both sides. And that leaves me with 6B equals what? 168. And then I'm going to divide by 6 and divide by 6. And I get that the bus holds what? 168 divided by 6 is 28. And again, it's 28 students. Now, if you want to leave it like this and not rewrite your answer, I'm fine with that. Just make sure that you do something along these lines to circle your answer. Okay, if you don't want a big drawn out box like that, come off to the side anywhere you want and put that V equals 10 students and that the bus holds 28 students. Now, as long as your variables connect with the story problem, I can obviously see that V stands for van and B stands for bus. So as long as your variables make sense, you can just leave it V equals 10 students. And I promise you, I will figure out that V stands for van. If you don't use variables that kind of match your story problem, then I do want you for sure to write out the word vans and buses. So if you used X and Y, at the end, I would want you to put vans, 10 students, buses, 28 students. If you use V and V, it makes sense that that's vans and buses, okay? So that is an example of one that isn't money related. So I wanted to do that. And then the first example we did, or the second example we did was an example of when you're solving for money questions. All right, now you had a question, go ahead.
Yeah, can you put two separate boxes?
Yeah, if you want to just square this and then square this, that's fine. As long as you circle your answers so I know what both your answers are. The main thing with story problems is labeling. If it asks how many students, your answer needs to be so many students. If it asks how many bushes, your answer needs to be 14 bushes. If it's how much money or what's the price or what's the cost, then you always need to put that $sign on your final answer. But in some way, every story problem needs to be labeled. And for all of these, because it's a system of equation, you're always solving for two things. You need to make sure that you have two solutions. So number of students in vans, number of students in buses, cost of geraniums and cost of tulips, whatever it might be, you're always going to have two answers to these, okay? All right, for those of you at home, go ahead and click on the load button and open up your assignment in Kami and email me if you have any questions.
Stop recording.